Hi, my name is James Charlot. I'm a researcher at the University of Malta. This paper focuses on understanding how changes in climate affect the distribution of species, especially terrestrial arthropods such as insects and spiders. Climate change threatens biodiversity by altering the habitats that species rely on. And since arthropods are present at various levels of the food web, changes in their environment can quickly propagate throughout the ecosystem. In this study, we present a new index designed to quantify species' climatic niche and predict its potential distribution in space. This metric uses the assumption that if a species is observed in a particular location, then that location must be favorable for its survival. So if we have a large sample of observations, we can begin to describe the climate conditions the organism prefers and look for similar conditions elsewhere. We start with a dataset of species observations, which includes geographic coordinates. In our case, we used public records from the iNaturalist platform. These observations allow us to extract climate variables at those points and build a statistical profile of the species niche. Our climate data comes from several models, including the ERA5 reanalysis, a small Eurocordex ensemble driven by CMIP5 models, and a high-resolution convection-permitting simulation focused on the Mediterranean region. We selected a set of climate variables that are biologically meaningful, such as average temperature and precipitation, as well as extremes, such as consecutive dry days and heatwave frequency. The method makes use of the descriptive statistics for each variable within observed locations of a species to define the relevant climatic niche. The product of each variable is then combined, producing what we call the EcoClimate Index, a value between 0 and 1 that estimates habitat suitability. To test the method, we focused on several terrestrial arthropods in the Mediterranean, using Spilostetus pandurus, a seed bug, as a representative case. It is important to note that this index doesn't show where the species is actually found. It maps where the ideal climate for the species occurs, which can be different from its actual distribution due to the influence of other factors such as competition and land use. The reliability of the result depends largely on the sample size of geographic coordinates for the species and, to a smaller extent, the horizontal resolution of the climatic variables. The EcoClimate Index enables climate-driven assessments of ecological vulnerability and can be applied to past, present, and future climate scenarios.